Hello everyone, and welcome back to a couple more practice problems. Today we have two related rates problems, and I hope that this video is helpful. Everyone finds this video helpful. I hope this video clears up some of your concerns, doubts, or confusions about related rates, and I hope that this video serves as excellent practice problems, and practice time for you guys to practice related rates. Now the first question, a small drone is flying horizontally at an altitude of 12 miles with a speed of 50 miles an hour as it flies past a tower. How fast is the angle of depression changing between the plane and the tower when the plane is 13 miles from the tower? Now first, we make a diagram. So this side length is going to be 12 because that is the altitude. That's how high the plane is compared to the tower. This side length is 13 because it says when the plane is 13 miles away from the tower. So the distance between the plane and the tower is represented by this side length, which is 13, and the remaining side length is x because the plane is moving at a speed of 50 miles an hour. That means that x is constantly changing. And as we can see here, that dx over dt is actually equal to 50 because as time increases, x changes at a rate of 50 miles an hour. So x is increasing and dx over dt is equal to 50. And overall, we want to find d theta over dt. So we set up our equation as theta is equal to tan or inverse of 12 over x. And we set it up in this format because me personally, I want to isolate theta. I want to isolate what I'm differentiating for so that it just makes it easier and more convenient for me when I'm solving. So differentiating both sides, we get d theta over dt is equal to d over dt of 12 over x would be negative 12 over x squared times dx over dt. So we have that as our inner chain rule times dx over dt. And then we just multiply it times the overall. So 1 over, tan inverse of u. So 1 over 1 plus u squared, so 12 over x squared. Squared. And we won't get far with this equation because we don't actually know what x is. We don't know what the variable to plug in. That's where the problem being a right angled triangle is very helpful because we can use the Pythagorean theorem to solve what x is. So x squared plus 12 squared is 144 is equal to 169. So we know now that x is equal to 5. When this side length is equal to 13, x is equal to 5. So knowing that, we plug in x equals to 5 here. So d theta over dt at x equals 5 is equal to negative 12 over 25 times dx over dt we figured out as 50 previously, and times 1 over 1 plus 144 over 25. Solving, we get negative 24 times 25 over 169, which is equal to negative 600 over 169. If you don't have a calculator and when you're solving this problem, just leaving it in this fractional form is good enough. But in this case, I want to make it a decimal, so my final answer would just be d theta over dt at x equals 5 is equal to negative 3.55 radians. And it's an important, very important thing that you're saying radians because you cannot use degrees in this case, as degrees is never stated in the problem. It's part of curriculum, I'm pretty sure, that if an angle measure is not specifically stated to be in degrees, it's always safe to assume that it's going to be in radians. So our answer is negative 3.55 radians. And now that we have our answer, we can just write our final sentence. So that would be the measure of the angle of depression. Actually, let me write this a bit clearer. My fault. The angle measure, the measure of the angle of depression is decreasing at a rate of 3.55 radians per hour when the plane is 13 miles away from the tower. The tower. And that is our final question sentence with its answer in the right units as well. The next question. Sand is being poured onto a cone-shaped pile of sand at a constant rate of 5 pi cubic feet per second. As the pile grows, it maintains its conical shape. The radius at time t is given by r of t is equal to square root of t plus 1 plus 2, for t is greater than or equal to 0. At time t equals 3, the height is 6 feet. At what rate is the height increasing at time t equals 3? So we drew another diagram here. It is a cone. The pile is growing as a cone and sand is being poured onto a cone-shaped pile of sand. And we know that we need to create an equation for volume because sand is being poured at a constant rate. And what that basically means is that the volume is increasing. So volume is going to be our relating equation here. And also, given that pile of sand is being poured at a constant rate of 5 pi, dV over dt is equal to 5 pi, meaning that the volume is increasing at 5 pi cubic feet per second. In this diagram, we can see that the height is 6 because we are given that in the problem, and the radius is, we're going to find the radius in the future. And what we need to find is d height over dt at t equals 3. So at time t equals 3 seconds. And so let's differentiate. So dv over dt is equal to pi over 3 is a constant, so it does not it can come out of the differentiating equation, and pi over 3 times 2r height times dr over dt plus r squared times d height over dt. And this is just product rule. So far, so good. Now we have a lot of variables that we need to eliminate. We need to eliminate r, we need to eliminate the radius, the height, and dr over dt. Now, we already know that the height is equal to 6 at time t equals 3. We also can find r very easily because we are given an equation that relates the radius to time. So we can just say r of 3 is equal to square root of 4 is 2, so 2 plus 2 is equal to 4. So the r is equal to, radius is equal to 4. And to find dr over dt, we could just differentiate the equation of r. So just differentiating both sides of this equation right here. 2 square root t plus 1. And chain rule would just multiply times 1. So dr over dt is equal to 1 over 2 times square root t plus 1. And what we actually can also further do is find what the rate of change is for the radius at time t equals 3, since we're solving basically this entire problem at time t equals 3 seconds. So that's going to be 1 over 4. And now that we have all of our variables found, we can just plug them into this equation. dv over dt was 5 pi from the question. Pi over 3 times 2 times r times height, so 2 times 4 times 6 times 1/4. So it's just 12 plus r squared, so 16 times d height over dt. Now 5 pi is equal to 4 pi plus 16 pi over 3 times d height over dt. Pi is equal to 16 pi over 3 times d height over dt. And our d height over dt at time t equals 3 is going to be 3 over 16. That's actually important. I forgot to put that. We have to make sure that all of these are specific to the time as t equals 3. Because we found all of these variables when given that time t equals 3. So we need to explicitly state that when we're trying to find d height over dt. And there we go. We found d height over dt to be 3 over 16. And what are the units? Feet per second. So feet per second. We can box this if we want to. Oh, bad box. And now all is left is our final sentence. So our sentence can go like, what is it asking? So the height is increasing at a rate of 3 over 16 feet per second at time t equals 3 seconds. So the height is increasing at a rate of 3 over 16 feet per second at time t equals 3 seconds. If you want to be really fancy, you could just say that the height is increasing at a rate of 3 over 16 feet per... the height of the pile of sand is increasing at a rate of 3 over 16, and so forth. But this is the final answer, final sentence as well. I hope you guys liked these two problems, found it good practice, and I'll see you next time.